What keeps the continents floating on a sea of molten rock? The continents do not float on a sea of molten rock. The continental and oceanic crusts sit on a thick layer of solid rock known as the mantle. While there is a layer of liquid rock in the Earth known as the outer core, this layer is about 3,000 kilometers below the Earth's surface and is separated from the surface by the thick solid mantle. The tectonic plates do not slowly drift over time because they are floating on a layer of liquid rock. They drift because they are sitting on a layer of solid rock, the upper mantle or asthenosphere, that is weak and ductile enough that it can flow very slowly under heat convection, somewhat like a liquid. If there is not a giant sea of magma under the continents, where does lava come from? The molten lava that spews out of volcanoes is created locally right under the volcano rather than being released from a global sea of magma. Magma is created when pressure changes melt the rock. For instance, as two tectonic plates collide, one plate may get forced under the other plate. As it does so, the plate that is forced down, subducted, releases water into the upper mantle, which lowers the pressure enough to melt the rock. Localized regions of magma form in the mantle near subduction zones. The mantle can then rise and create volcanoes. The point is that magma is created in small pockets, small relative to the size of the Earth, as part of the tectonic plate movement, and does not exist as a global sea of magma just under the crust. The confusion about the state of the upper mantle perhaps arises from the way diagrams are presented. For instance, the image above shows the mantle in a glowing orange color. This coloring can be confused to mean that this layer is hot liquid rock, like lava. In reality, the mantle is solid, and the coloring is just meant to indicate that the rock is hot and flowing slowly under heat convection. The textbook Physical Geography by Robert Gabler, James Peterson, L. Trapasso, and Dorothy Sack states, extending down from the base of the lithosphere about 600 kilometers, 375 miles, farther into the mantle is the asthenosphere, from Greek, asthenias, without strength, a thick layer of plastic mantle material. The material in the asthenosphere can flow both vertically and horizontally, dragging segments of the overlying, rigid lithosphere